in welcoming Kiri. Thank you.
Can everyone hear me okay? Yep, great. Right, okay, let's get into it. So I'm going to start by asking you a question. Where have our native forests gone? And this is a bit of a depressing question, I know, but it gets better from here. Unfortunately, a lot of our native forests are gone, both from the rural parts of the country and the urban parts of our country as well. And in their place, we have a lot of introduced species, like these pasture grasses and radiata pine. So you might ask, okay, well, our indigenous forest cover has been greatly reduced, and well, why is this a problem? Well, it turns out that our ecosystem services are greatly reduced as well. Now, ecosystem services are all of the benefits that people obtain from natural ecosystems and native ecosystems. Things like clean drinking water, decomposition of waste, pollination, and the list goes on and on and on. These are vital things that we require. And there's a lot of research these days that proves to us that these come most efficiently from intact natural areas. So these are valuable areas. So we might not be able to go find a barcode on a tree like this, but we might as well be able to because nature is very valuable to us. And beyond even those economic reasons, our well-being is connected to nature. It's very important for each and every one of us to spend time in green spaces for our own well-being and benefit. So now I'm going to bring a new concept into this talk, which you've already been hearing about from others, which is this idea of restoration ecology. And this is our pathway back to regaining some of those valuable ecosystem services. It's a scientific study of repairing these disturbed ecosystems through human intervention. And it's kind of, for me, a nice, hopeful ray of sunshine amongst the loss of the indigenous nature. Now, Bruce showed you this slide before, but I want to show it to you again just to bring this home, that 87% of us live in cities. And so I think we deserve to have nice places to live, don't you? With lots of nice green spaces that are beneficial for us. So what if we seize this opportunity that our city parks offer us to do a bit of restoration work? We can promote biodiversity of our native flora and fauna, which is very special and unique in the whole world. We can make more nice green spaces for our recreation, whether it's just a picnic or walking the dog or going for a run. We can get more of those really precious ecosystem services provided within the city, so that urban footprint that Bruce talked about, we can start to provide some of what we need from within the city itself, and not just from outside of it. And this might be one of my favorite reasons for restoring nature in cities, is that people become nature advocates, because we care about what we know, and those are things that are close to us. So if you get to know your local park and the forest there, then you may find that you're suddenly much more supportive of wild native places further afield in the rest of the country as well. Now, there are a lot of cities and countries around the world who are emphasizing this idea of urban nature. The US Department of Agriculture put out this booklet last year. London is all about its street trees and its own urban forest. And Johannesburg has created the Urban Forest Alliance. And across the ditch in Australia, they're really investing in urban forests, especially in Melbourne. Very impressive. They are starting to realize how important trees are in their city infrastructure for reducing heat, amongst other things, so keeping those heat levels down because it gets horribly hot. So I would like to ask, is Christchurch benefiting from urban forests as much as it could? Or perhaps we could do with a little bit of restoration here and across all of New Zealand? If so, there are a few keys to urban forest restoration success. First of all, I advocate we move from a revegetation mindset to more of a restoration of ecosystems mindset to capture all of the benefits. So the difference here is not just plonking some plants in the ground and saying, well, that's green and nice, but saying we want to create a vibrant living ecosystem. I think another important key is to patiently and respectfully work together. As we all know, there are a lot of stakeholders in city areas, and this is actually really great because it can support a project for a longer amount of time if you create that foundation in the first place where people cooperate and have a common vision. It's also very important, coming from the scientist, to use scientific underpinning in order to be efficient when you do restoration work and achieve that long-term success. We're talking about forest ecosystems, that's what I study. They're going to last, we hope, much longer than any of us. So we need to get them off to the right start for that to happen. Now I'm going to tell you a little bit about the research aim that I'm part of in the People, Cities, and Nature project. And I'm focused with my team on restoration plantings research. So how do we actually create these urban forests again? First of all, here's the team. So this is a subset of all the people in the People, Cities, and Nature program, and we'll be hearing from more of them later today. Here's Bruce up in the top right, and I want to point out Kat De Silva in the bottom left. She lives in Wellington, but actually did a lot of data collection here in Christchurch and other South Island cities. Now, what do we do? Well, we use a nationwide chronosequence framework for our research. This means we've got research plots across the whole country, and they are built in a chronosequence fashion. So there are forests that we study that are really young, from like 5 years old, all the way up to very old, like 50 or 60 years since they were planted. So kind of showing that here. So this is because we want to see how these forests change over time, but I don't have time to plant something and monitor it for the next 50 years, right? So we need to use what is already out there. Now, what we're most interested in is something that Colin was just talking about, which is regeneration. So not just that first planting, although we need to do that correctly, but how do we create a forest that's going to self-perpetuate? That's what we want, right? We don't want to become eternal gardeners if we can help it. So we want to study what makes these forests that we've planted regenerate themselves. And we want to look at that across a lot of temporal dynamics of climate, microclimate, and what species are growing in these forests. Now, you've known that you have successfully created a forest if you have these two indicators within that forest. First of all, native tree regeneration, especially what we call late successional trees. So these are some of the forest giants that need special conditions to establish, but then they're there for hundreds of years. They're pillars of the ecosystem. And also, epiphyte colonization is a great sign that you have restored a forest. Epiphytes are plants that grow on trees, and they're very sensitive, very precious plants. So they need just the right conditions as well. So both of these are late successional plants that need a closed forest canopy to be able to survive. And this canopy is important because it provides a stable microclimate for these late successional plants. So I can sum that up for you here with this diagram. So over time, we may at first have a canopy that's quite open, a young forest you just planted maybe 5 or 10 years ago. But over time, that canopy is going to close, hopefully. The weeds are kept at bay. And at the end, you're going to have something like this that actually has very low canopy openness, and that's what we want for the next generation of forest to be able to establish. So to achieve this first threshold, we recommend the 1 and 1 rule. Plant really densely at first, if you can, 1 plant per square meter, and plant tall, plants that are about 1 meter tall. And this is something that will help you to then achieve that canopy closure sooner and help with that battle against the weeds that I know we all face. Something else we need to think about is not just the conditions that are right for these plants, but when do those conditions start to occur? Because we need to think about managing these forests. We need to think about our resources and our budgets. So we need to think about the time scale. So here, if you look at the x-axis of these plots, we can see time since restoration. So this is how old forest patches are, and each of these little dots is a forest patch. And we're looking at a couple of different variables here that are really important in forests. So canopy openness, that I've been talking about, we can see that it drops quite rapidly in the first couple of decades of a forest's existence. It gets to be quite a low level, which is good. At the same time, humidity fluctuation drops as well. So this is important because a nice stable, humid climate is important for these plants that we want to have regenerating. Soil temperature fluctuations also drop, so the temperature of the soil becomes more stable, which we want. And herbaceous weed cover just plummets because it needs that sunlight from the open canopy. So closed canopy means less herbaceous weed cover on the forest floor. That's going to compete with the seedlings that you want to have growing there. So my point here is that there are these thresholds that we can actually see where these variables trigger one another to occur. If we understand these thresholds and the time scale that they are occurring on, we can manage forests. So we can get these ecosystems past these really important thresholds in their development. And I even think of this kind of like, it's almost like people, right? We take 18 to 20 years before we get to a point where we're more independent. So forests need a little more time at first, but then they can get off on their own and need less care. Now for our research, we have locations or plots, research plots in 9 different cities throughout New Zealand. And there are 9 plots in every city, so we've got 81 plots across the whole country where we're studying these sorts of forest dynamics. We want to see if there are unifying principles that we can apply to forest restoration projects in cities everywhere. All of our plots are set up in native forest patches that have been planted from scratch. So most of them were pasture before, and then they were planted up. Here are our Christchurch plots. You might be interested to see where they are. All of these are permanent plots, and we can relocate them and set them up again in exactly the same place in order to be able to measure them over and over into the future. And they're generally on public or covenanted land, so that helps us with that access in the future. In Christchurch, they range from an 8-year-old planting to a 44-year-old planting. Actually, the 44-year-old planting's up in Rangiora. Couldn't resist including that one because it's so old. And help from locals was really critical in finding these plots and knowing how old they were, because we can't do the research without knowing how old the plots are. In all of these plots, we measure the canopy openness because it is that index of light availability and microclimate. And we also measure the microclimate itself using data loggers, like these ones here. So soil temperature is this little thing here that's buried in the soil. And then there's another one on a tree here to measure humidity and air temperature. We also have a look at the plants that are actually growing in these restoration plantings, both the adult trees and how big they are, and the seedlings that are regenerating, how many, what kind, and we look at the herbaceous ground cover too, and measure that. This is what our plots look like. They're standardized across the whole country, and they follow the National Vegetation Survey method that DOC uses. So what these really are is they are an urban forest counterpart to the National Vegetation Survey plots. Currently, all of our plots have been set up, and we've collected an entire year of microclimate data. So that means we've collected a data point every 4 hours for a whole year in every single one of these plots. We've tagged and identified almost 4,000 trees in all, and they're all identifying tags that are unique so we can track these trees from visit to visit. And we've done a preliminary data analysis on top of that. This winter, we're going to do a more complete countrywide data set analysis. But I'll give you a little peek just now into some of the data that we've got from Christchurch. So these plots are similar to what I showed you before. This one here is showing forest age on the x-axis, so this is years since planting. And every one of these points is one of the Christchurch research plots. And I'm showing on the y-axis basal area, so that is essentially how big a tree is. And what I want you to take away from here is that the trees are getting bigger as the forest ages. But wait, there's more than that. So at the same time, we're seeing this similar pattern to what I was talking about before with canopy openness declining over time. So these older forests have much more closed canopies. So that's what we want to see. That's good. It means the forest is growing as we would like. In tandem with that, herbaceous ground cover is declining. This is what we want to see. So that's not competing with regenerating seedlings. And the variable of most interest, the regeneration, we're seeing an increase over time. And we've got this Rickerton bush plot here where there's just seedlings that are more than anywhere else. So Rickerton bush is a remnant, like Colin was saying, but there were plantings done around the edges of it. So we're studying one of those plantings, an augmentation planting. And I think what we're seeing here is a really great combination of a forest planting that has achieved the conditions suitable for regeneration, next to a huge, huge source of seed, which is the remnant forest of Rickerton bush. So this is like the dream come true for restoration. Yeah, so I like that one. Now, if we were to look at just an urban forest remnant, so not a restored forest patch, but a remnant that has been left on the landscape, this is kind of where you would see the different values. You would see that basal area is about here, so we've got a little ways to go before the Christchurch plots get there. And canopy openness is really low, as is herbaceous ground cover. And tree seedling regeneration sits about here, so Rickerton bush's plot is actually well exceeding that. Here I've done, we're looking at about the same plots. However, I've taken away the names and I've added to the blue Christchurch plots, I've added Tauranga, Napier, and Invercargill forest plots in red. And all I want you to do is notice the shape here. So I've done a linear regression model, which basically tells us there's a statistical significance here between basal area and the age of the forest. So this is a reliable principle that's going to be happening everywhere now. And for canopy openness, we see again a significant relationship between canopy openness declining as forests age. So we're starting to be able to see this is something that happens everywhere that we can depend on and can plan for. Herbaceous ground cover is the same. There's this reliable curve, this drop over time. And then finally, same for tree seedling regeneration. So I'm really excited to see how the other cities that aren't in these plots, the other 5 cities, look when we add all of their points to the plots as well. And also this question of, is there a 20-year threshold everywhere, like we found in that earlier study that I talked about? So if you zoned out during that, here's the short version. Ready? As forests get older, trees get bigger, canopy openness is going to drop really reliably, and following that, the herbaceous weed cover will drop too, and the microclimate will get just right for those baby trees. And so at that point, you get tree seedling regeneration, which is the goal, and you've been successful if you've done that. So we need to think about timescales too. We need to remember there's certain thresholds to help our forests develop across. And as a wise man once said, it takes more than one generation to build a forest, so we need to transfer this knowledge to the next generation so they can keep taking care of these forests we've started. So I've run out of time. I have a couple of slides here that are kind of take-home points, but this will be available on our website, so I'm not going to go through all of these points now. You can just go have a look on the website to see those. And I'll just finish by thanking all of our partners, all of the councils who have worked with us to achieve this research. Thanks very much.